next speaker from the New York City Department of Environmental Protection, Dr. Sri Rangarajan. His title is the Director of Water Quality Planning and Analysis. He has got, it says here, 12 years of experience working on New York, New Jersey harbor-wide study. So I think if anybody has a good picture of overall water quality, it's probably Sri. Also teaches at Columbia. Sri?
Good morning. There are a number of monitoring programs as well as the modeling efforts that New York City has been doing well before the Clean Water Act came into place, and even well before the river burning was recognized and so on. So what I'm going to do is just a quick summary of these efforts in terms of where we stand at this time, and then kind of review some of the ongoing programs or the improvements to the programs that we are working on. So the two summaries will be on the harbor survey and then also the beach monitoring program that our sister agency, Department of Health and Mental Hygiene, works on. Modeling related to understanding what's happening in the individual CSO tributaries, Gowanus, Newtown Creek, etc. Sorry. And then the emergency spills, like the North River fire incident we had 2 years ago. I'm going to show some slides on how we developed the advisory information for that. And then where we are heading at this point. The harbor survey program, it goes back over 100 years. You know, the instrumentations have changed, the number of parameters have been added and so on, but still it gives a very good idea of, when you look at the historical water quality. This 100-year report was published in 2009. The harbor water quality has been at its best, historically speaking. Still, we recognize that we have a long way to go, but definitely if you look at the overall water quality, has been at its best. And there are over 70 stations, as you can see through this, with these blue dots, in Jamaica Bay, into the East River, into the Hudson, and so on. Typically, we do a weekly sampling in the open water season from about June to September, and then once a month during the other months. Number of parameters, again, we started with the conventional parameters like dissolved oxygen, coliform bacteria and so on. But a lot of parameters have been added, something in excess of 30 or 40 different parameters. We keep adding more stations as we do more CSO control projects. For example, the Farragut Basin, the tank retention facility has been added, the Alley Creek retention facility in Lilith Bay, Alley Creek. So when we do that, we actually increase the number of stations. This is an example of the Alley Creek, where we went in, added 3 more stations to understand the pre-tank construction scenario, to understand what the current quality are before construction qualities, and then what the tanks make as difference related to water quality improvement. So this is certainly a key piece that we use for various purposes, understanding the long-term water quality improvements, also to support the model calibrations. This is the longer-term data, because usually when you do a targeted monitoring, you do it for 3 months or 6 months or whatever, but you need to understand what's happening over several seasons, several years, under different precipitation conditions and so on, to know what's happening in the system. So we use this longer term data to support that analysis. Similarly, the Department of Health's beach monitoring program, the public beaches are shown in green and the private beaches in pinkish color. So they are looking at it from a primary contact perspective. So they typically go from 7 o'clock in the morning to 9 o'clock when people are not in the beaches, disturbing the shoreline. So they go to the wading level and then look at 3 areas within each beach, left, right, and center to understand the pathogen levels. And then if and they compare it with the 30-day geometric mean of 35 for enterococci indicator organism. And when it exceeds that 104 threshold that they use for issuing an advisory. And when they see higher levels, they tend to go on the following day to see, has it come down to levels, below the 35 or the 5 sample geomean that they look for, and then they open up the beach. They also have more frequent sampling in some of the popular beaches, Orchard Beach, Coney Island, and so on, as compared to some of the private beaches, that are less frequently monitored. Modeling approach. The first model with the fancy computer, that was probably this room big, was done back in the 60s. But over time, we have evolved into more powerful computers, more refined representation of the harbor estuary area. I just want to summarize them. The system-wide eutrophication model that covers an entire bigger domain. It goes into New York Bight, all the way to Long Island Sound and so on. East River tributary model, that's more like a smaller representation of zoomed-in version of the East River, Upper and Lower East River, along with the tributaries. Jamaica Bay estuary model, that's meant for Jamaica Bay, and it's a linkage with the lower New York Bay. So these are the modeling tools that we use at this point to develop advisories based on secondary contact recreation. So the standards that are used as threshold are the fecal coliform standard of 2000 per 100 ml as the geometric mean. With the model, you're able to develop information at hourly intervals, and then you can average based on any period that you're interested in. This monthly geomean is the current standard for the secondary contact. And when the levels exceed 4,000, that's when we issue an advisory, and then until it really comes back to the 4,000, the advisory stays in place. So with each tributary watershed, and I think Franco put that in a nice way, you have individual sewer sheds responding differently to different rainfall events, whether it's a volume or intensity and so on. So you're able to understand what the estimated overflows or stormwater discharges coming from different outfalls, and you're able to then simulate the response of your water body depending on the bathymetry and then the tidal exchanges, temperature conditions, wind effects, and so on. You're able to predict what the endpoint or the water quality conditions look like. And you can look at it for a longer period of time, 12 hours or 24 hours or 36 hours, and then say, in this particular water body, for this type of rain pattern, the levels are likely to exceed this 4,000 for 24-hour period or 48 hours period. So that's what you're seeing in our website, which I think I have in this one. So the New York NYC.gov DEP. Under that, if you go into the harbor waters link, it should be one of those here, and you can look at the current water body advisories. And the way it would look like is that you put the NOAA gauge data that you will see in here, and then okay. So that circle is the NOAA rainfall information. NOAA meaning the National Oceanic and Atmospheric Administration gauge. And that's where there's a room for augmenting that network. Currently we use the 4 gauges maintained by this federal agency to guide the advisory, but we can always supplement it with increased rain gauge network. So then it gives you, if the color is blue, then there's no CSO advisory, and then if it's red, there is a CSO advisory in a specific tributary. So if you go into all of New York City, then it gives you this whole picture, but then if you go, you can zoom into Newtown Creek or Gowanus and then look at the advisory for that area. So how does it get translated to agency usage? So we get the real-time information from the gauges for the to support the advisory, and then we have developed regression curves or the rule curves that we can use based on the volume of rainfall and the specific nature of a certain water body as to how it reacts. So and then we develop. So this is what we provided to the Department of Health. For each beach, for a certain type of rain event, what's the duration of advisory that they will have to work with. So same thing, there's one more slide. This is a public advisory you will see in every CSO outfall. For the spills, what I showed earlier are all for understanding like rainfall related impacts, but you also get impacts from things like the North River fire incident, or there were a few that we wrestled with in the last year, like for the Ironman competition. There was a concern whether Hudson was safer to swim in. So this is a model of larger geographical area going into the Long Island Sound and then into the Bight, where you are able to put in the discharge. For example, the fire incident lasted for 2 days or 3 days, and then you are able to put in the sanitary flow and then understand how long that would stay and how far would that go. So I have some screen shots. So we have, since this is done on a sort of real-time basis in a sense, New Jersey DEP and several harbor entities use this model, where you are able to put in your own coordinates of where the spill occurred, and then you can actually use the model online to simulate it and then see how far the red representing high levels of contamination progresses. So this is for the advisory for Newtown Creek, for example, for this rainfall total of 1/10 of an inch to 1.3 inches, what the advisory would look like. So you have, I don't know if you're subscribed to that, but you typically get emails twice a day based on this type of an advisory, citywide or for the specific area that you may be interested in. Another example is this North River incident. When this happened, the treatment plant is right there, just when it began. What you see is the red is levels exceeding, I believe, 500 coliform units per 100 ml. And then we could see that, sometime later, I believe it's after a day or so, it went all the way up to, the South Beach and so on. So we had to issue some advisories all the way up to that point. So where are we heading? We certainly recognize that there are a number of improvements that could be done, and we want to experiment on a demonstration basis. For example, current advisories, they are based on model simulations that go up to 2.5 inches or so, but we've seen many rainfall events in excess of that, so we are updating that information to go up to 6 or 7 or 8 inches of rainfall events. And then in terms of the CSO monitoring, it's one of the complex things that you can ever imagine. The way the structures work is that you have the regulator structures, depending on the tidal conditions, even though there may be 10 feet of water sitting upstream of the regulator, it may not be able to get out because the tides are sitting like a water wall on the other side. So to be able to understand, the spatial variability in rainfall and how that generates the runoff, and then what fraction goes into the treatment plant versus what gets out. That's where we do this complex watershed modeling, or sewer shed modeling. And we are at this time experimenting at 5 CSO outfalls, large outfalls. So we have to put like 3 or 4 sensors in the incoming pipe, 3 or 4 sensors in the outfall pipe, 3 or 4 into the what goes in, towards the treatment plant side. And then sometimes the velocity really gets to 0 or 0 or negative values because of the higher surcharge conditions within the sewer. So we need to supplement it with depth sensors and so on. There's a lot of instrumentation put into these 5 outfalls to understand how these work. And there's a peer review process ongoing involving multiple municipalities and experts to guide that process, which we should be wrapping up towards the end of this year. And then incorporation of the weather forecasting. Currently we are doing it on a hindcasting mode, in the sense, 2 inches of rain happened yesterday. Based on that, we issue the CSO advisory. But instead of that, is there a way to look forward, using some forecasting tools? There's always, the Stevens Institute has developed an IHOP system that guides us more in the hydrodynamic side. Can we add water quality piece to understand, what the impact of the 1.2 inches anticipated in the next 24 hours is, and then kind of issue the advisories ahead of time. So we're looking into several of these. I'll be updating on those in the future meetings. With that, I'd like to wrap up.